Welcome to Maths Classes 7-8 CBSE by GK Pillai. This chapter of class 7th Maths by name Expressions Using Letter Numbers is about algebraic expressions. As per the revised syllabus of NCERT, algebraic expressions is being taught for the first time in class 7th only. By the time you completely watch my video, you will get a clear idea about algebraic expressions. I have already discussed about algebraic expressions in my video on finding the unknown or solving equations of class 7th. Some textbook questions are also worked out in this video. More videos on answers to textbook questions and practice questions will be available shortly. Subscribe to my channel and tell others also to do so. More subscribers are an essential part of my efforts in preparing these videos. So, expressions using letter numbers or algebraic expressions. This is a very simple definition of algebraic expression. Mathematical expressions containing letter numbers are called algebraic expressions. These are mathematical expressions as well as algebraic expressions. Letters such as A and S that are used here to represent numbers are called letter numbers. Actually, these letter numbers are to represent numbers only. We use operations of addition, subtraction, multiplication and division using these letter numbers and also numbers to form algebraic expressions. You will understand about this here. For example, the expression 4xy plus 7 is formed using letter numbers x and y and on the numbers 4 and 7. You will find some more examples of algebraic expressions: 2y minus 5, 3x plus 5, 3x squared, y plus 1, etc. You can have many examples of this. Something more about algebraic expressions. Algebraic expressions are central concept in algebra. Simple equations are also made out of algebraic expressions only. The chapter Finding the Unknown about solving the equations, there also we use algebraic expressions only. A letter number can take any value, its value is not fixed, but a number or constant has a fixed value. Now there are some advantages of algebra. You will be able to understand in detail about this later on. Patterns or relationships written or explained in long and complex ordinary language can be easily written using algebra. There are many examples of this. Algebraic expressions can be described in ordinary language and vice versa. These things I'll be able to discuss later on. Forming algebraic expressions. You will get a very basic idea about forming the algebraic expressions. First one, 1/4 of the product of numbers p and q, 1 by 4 pq. Number 5 added to 3 times the product of numbers m and n, mn plus 5. Sum of numbers a and b subtracted from their product. The product will be ab minus, within bracket it should be a plus b. Describe situations corresponding to the following algebraic expressions. These are algebraic expressions only. What are the situations leading to this? 5 multiplied by x, this, and added to 7 multiplied by y. We simply write this one as 5x plus 7y. Here it is explained clearly. Second one, 11 into j minus 5 into k. 5 multiplied by k is subtracted from 11 multiplied by j. 10p plus 7. P multiplied by 10 and then 7 added to the product. Then x is multiplied by 5 and the result is subtracted from 16. 16 minus 5x. It is not necessary you should write this way only, or the explanation this way. You can reduce this part and write in very simple language also. Formulas are formed using algebraic expressions. In the chapter areas, you must have seen we require formulae like perimeter of a square, area of a square, area of a rhombus, etc. There we use letter numbers only. Use of letter numbers and algebraic expressions help us to express general mathematical relations called formulas. Examples: formula for finding the perimeter of a regular hexagon. A hexagon has 6 sides. If you keep one side to be A, the perimeter will be 6 into A or 6A. This is a mathematical relation, or you can call it as a formula only. Perimeter of a square with side 7 cm. Let one side of the square be P. The perimeter will be 4 into P or 4P. Now the perimeter when side is 7 cm, side length 4 into 7, 28 cm. Area of a rectangle is L into B. Similarly, you can find anything. Here the heading is Revisiting Arithmetic Expressions. We had a chapter by name Arithmetic Expressions. We learned many things. Here from the chapter Arithmetic Expressions we learned all these things. To write expressions as sums of terms, there we use the word terms, and it became easy for us to read arithmetic expressions. This is applicable in the case of algebraic expressions also. That is why we are writing this. We are learning this. Swapping, adding two numbers in any order. Grouping, adding numbers by grouping them conveniently to find easy ways of evaluating expressions. Swapping and grouping terms does not change the value of expressions. These three, swapping, grouping, and here, that does not change the value of expressions. This is equally applicable to algebraic expressions also. To use brackets in expressions, including brackets with a negative sign outside. We have seen in many sums in arithmetic expressions, there can be a plus sign before a bracket. There can be a negative sign also. When the negative sign is there, the numbers inside the bracket, the sign changes. Here also the same thing will be applicable in your algebraic expressions also. Distributive property is very much there in the algebraic expressions. The rules for manipulating arithmetic expressions, that is what we have been doing there. Like commutative property, associative property, distributive property, etc. also apply to algebraic expressions. This is what I was telling you here. These rules can be used to reduce algebraic expressions to their simplest forms. That is the reason why we are using arithmetic expressions. Whatever the rules we had in arithmetic expressions, we will be using it in algebraic expressions also to reduce the algebraic expressions to their simplest forms. Omission of multiplication symbol in algebraic expressions. Till now, we used to write the algebraic expressions this way: 4 into n, 5 into p plus 7 into q, and 2 into bracket 3 into m plus 5. But as a standard practice, the multiplication sign is avoided while writing the algebraic expressions. So instead of 4 into n, we write 4n. Instead of 5 into p plus 7 into q, we write it as 5p plus 7q. Instead of 2 into 3 into m plus 5, we write it as 2 bracket 3m plus 5. It is very essential you understand the difference between some algebraic terms. Here 7y and 7 plus y, these are entirely different. 7y means 7 times y, and 7 plus y means 7 more than the number y. So there is a big difference between 7y and 7 plus y. Another one, 10m minus 3 and 10 into m minus 3. 10m minus 3 means 3 less than 10 times m. 3 less than 10 times m. 10 into m minus 3 means 10 times 3 less than m. M minus 3 means 3 less than m, and 10 is outside the bracket, so it will be 10 times this. Whatever you simplify and get m minus 3, that multiplied by 10. Another one, simplify the expression, this one. 5 into x plus y minus y means you just open the bracket, 5x plus 5y minus y. And 5y and y, you can simplify it further as 4y. This is using distributive property. These are some questions on simplification of algebraic expressions. These questions are from the textbook only, but I have taken limited number of questions which are of different types. The first one, and these sums are definitely important. You will get this type of questions surely in your exams. 3a plus 9b minus 6 plus 8a minus 4b minus 7a plus 16. Let us combine the like terms 3a, 8a and 7a. And the like terms 9b and minus 4b and these number terms. Now let us take a common for all the three. Within bracket you will find 3 plus 8 minus 7 into a. And the same way b here, 9 minus 4 into b. Within bracket minus 6 plus 16. So this will be 3 plus 8, 11, 11 minus 7 is 4, 4a. 9 minus 4, 5, 5b. And this will be 10. Another one, bit different. 23 plus 4 into 6m minus 3n minus 8n minus 3m and minus 18. You just open the bracket. This will become 24m and this will become 4 3s are 12n and the remaining as it is. Now combine the like term 24m minus 3m minus 12n minus 8n minus 18 plus 23. Here m common, 24 minus 3 brackets within bracket. And here when you take n common, it will be minus 12 minus 8 within brackets, and there is a plus sign here, plus 5. When you simplify these two, you will get 5. So now this will be 21m and this will be minus 20n and plus 5. Another one, 8x minus bracket 2x minus 3 plus 12. When you open the bracket, the signs will change. 8x minus 2x plus 3, minus into minus will be plus 3 plus 12. So it is easy to simplify this. 8x minus 2x is still 12x and this will be 15. Now another one, 3 into 3a minus 3b within bracket and minus 8a minus 4b minus 16. Open the bracket, it will be 9a minus 9b minus 8a minus 4b and minus 16. Combine the like term 9a and 4a, minus 9b and minus 4b and minus 16. So this will be 9 minus 8 within bracket and a outside, minus 9 minus 4 within the bracket and b outside, and a plus sign here, and minus 16. This will be 1a or just a, and this will be minus 13b minus 16. Here 2 into 2x minus 3 plus 8x plus 12. Open the bracket, 4x minus 6 plus 8x plus 12. Now combine these two like terms and plus minus 6. 8x plus 4x is 12x and this will be 12 minus 6 will be 6 only. Another sum, 8h minus 5 plus 7h plus 9. Open the bracket, change the signs. 8h minus 5 minus 7h plus 9. So it will be 8h minus 7h plus 9 minus 4 equal to h plus 5. This will be 5 and this will be 8h minus 7h will be 1h or just h. We have just seen how to simplify algebraic expressions. Here we are having 4 sums. 2 for adding the two expressions, and here subtracting one from the other one. Here there are two terms, two algebraic expressions. We have to add them. Write the two terms with a plus sign here, then combine the like terms. After that, here from these two terms we will take d common outside, and from these two we will take c common outside. Now when simplified, you will get 13d plus c. This is 8 minus 7, 1c only or c only, minus 2. Let us write in the proper order, c first and d later. C plus 13d minus 2. And here we have to add these two. Let us write the two terms with a plus sign here. And now properly, here we have to open the bracket and simplify. 8d minus 14c plus 9 plus 16c, and this will be minus 11 minus 9d. Combine the like terms here, and from the two terms we will take d common. From these two terms we will take c common outside. So this will be 8 minus 9d, and this will be within bracket minus 14 plus 16 and c outside and minus 2. 9 minus 11 is minus 2. Now this will be minus d plus 2c minus 2. We have to write in the proper order. It will be 2c minus d minus 2. Here subtracting one expression from the other one. Subtracting this from this, write this first, later on put a minus sign and write this one. Open the bracket and change the sign. This minus 15x will become plus 15x, this will be minus 13, and this will be plus 9y. Now we can combine the like terms and take x common from these two, y common from these two, and simplify these two. It will become minus 23. This will be 3 plus 15, 18x, 7 plus 9, 16y, and this 23. So this is the final answer. Now here another one. Subtract this from this. Write this first. 6a minus 9b plus 18 minus this expression. Now you have to open the bracket twice. Here also you have to open the bracket, here also. Here it will be minus 9b minus 18 minus 9a plus 6b, and this is minus 14. Combine the like terms and then take a common here, b common here. So what will happen? It will be 6 minus 9a and minus 9 plus 6b and minus 32. When you simplify this, minus 3a minus 3b and minus 32. So we have seen simplification of algebraic expressions. One straight away simplifying, another one add the two expressions and then subtract. These sums are actually from your textbook only, but I have taken for giving you some practice. I will be discussing just one sum of this type. There are many examples of this type in the textbook. I will be discussing some of them in my next video. Along with that, answers to the textbook questions and also practice questions will be there in my next 1 or 2 videos. This I will be discussing briefly, as you can see here. A shop rents out chairs and tables for a day's use at the rate of rupees 40 per chair and 75 per table. When the furniture is returned, the shopkeeper pays back rupees 6 per chair and rupees 10 per table. The shopkeeper must be taking this much as advance only for the safe return of the tables and chairs. Write an expression and simplify for the amount paid if X chairs and Y tables are rented. The answer is very simple. Total amount paid in the beginning will be 40x plus 75y. 40 rupees per table, per chair, and 75 per table, and X chairs and Y tables. So it will be 40x, 40 into X will be 40x, and 75 into Y will be 75y. Total amount returned by the shopkeeper when the chairs and tables are returned, that will be 6x plus 10y. 6 rupees per chair and 10 rupees per table. So this is the amount returned, this is the amount initially paid. Now the total amount received by the shopkeeper will be this minus this, 40x plus 75y minus 6x plus 10y. Now you have to open the bracket by changing the sign of these two and simplify. Simplify means 40x minus 6x plus 75y and minus 10y. That will be 34x plus 65y in rupees. That is the amount received by the shopkeeper. There is a matchstick pattern or matchstick arrangement sum on page number 100 of your textbook. I am just giving a brief answer to that particular question. You can read the question from your textbook. Arrangement at position 1 has 2 into 1 plus 1, 3 matchsticks. Position 2, 2 into 2 plus 1, 5 matchsticks. Position 3, 2 into 3 plus 1, 7 matchsticks are there. So if you continue this way, you will reach the nth position. Then the number of matchsticks will be 2n plus 1 matchsticks. Now the matchstick arrangement using exactly 99 sticks. Here also we are talking about matchsticks only. So we will equate 2n plus 1 with 99. N1 will go to the other side. It will be 99 minus 1, 98. 2n equal to 98, n will be equal to 98 upon 2, that will be 49. The value of n will be 49 if there are 99 sticks. Here you will find a heading beyond your textbook. As I have already discussed in my previous videos, many of you must be having books from private publishers, or your teacher might be teaching something beyond your textbook in each chapter. The definitions and questions I am including here will be of definite help to you in such a situation. Monomial, binomial, trinomial and polynomials. Whatever I am discussing here, these are very relevant to your present chapter. Expression that contains only one term is called a monomial. Here you will find all having only one term, 4x squared, 3xy, minus 7z, etc. Expression that contains two terms is called a binomial. Here you will find two terms, a and b, a plus b, 4l plus 5m, a plus 4, etc. These are all algebraic expressions containing two terms, and it is called a binomial. An expression containing three terms is called a trinomial. Here you will find three terms, a plus b plus c, 2x plus 3y minus 5, etc. In general, an expression containing one or more terms with non-zero coefficient is called a polynomial. This is a proper definition of a polynomial. A polynomial may contain any number of terms, one or more than one. Even if there is one term, we can call it as a polynomial. Whatever I will be discussing here, this also comes under beyond your textbook. Like and unlike terms. Sets of terms such as 5m, minus m, 7m, and another example 12a squared b and minus 4ba squared, that involve same letter numbers are called like terms. Here you will find the letter number m only, m, m and m. Here the letter number a squared b, and here also it is a squared b. Even if we write b a squared, it will be a squared b only. So these are examples of like terms. These three are like terms, these two are like terms. Sets of terms such as 18c, 11d are called unlike terms as they have different letter numbers. Like terms can be added together and simplified into a single term. Unlike terms cannot be. As I have already indicated, please don't forget to subscribe to my channel and tell others also to do so.